Before we start the application of derivative, first let's have a look at how does a secant becomes a tangent. So here is a curve. This is a point P, this is a point Q. We call PQ as the secant. How can the secant be converted to a tangent? Imagine this is a position Q1. Let's say the position became Q2. The point Q2, Q1 has moved to Q2. The secant will become in this manner. Let's say Q2 became Q3. Then the secant would be in this way. Let's say Q3 became Q4. So as the Q is approaching to the point P, you will notice that the tangent secant at P, secant PQ will get converted to tangent at P. This is an idea that we are going to apply to find the slope of the tangent. So when Q approaches P, secant PQ will become tangent at P. Now we will use this to derive the slope of the tangent. We shall construct a curve and mark the coordinate of P in this manner. Let's imagine this is the coordinate axis. Let's say the curve is in this manner. Here is the point P, whose x coordinate is A, and the equation of the function is y equal to f of x. So the coordinate of P would become A comma f of A, which means distance from O to this point is A. We will take the coordinate of Q at this position. Let's say the distance between the 2 points be h. So this became A plus h comma f of A plus h. First I will calculate what is the slope of PQ. So slope of PQ we calculate using y2 minus y1 upon x2 minus x1, which will become f of A plus h minus f of A upon h. Now this is the slope of secant PQ. I have just before told you, when does PQ becomes a tangent? When Q approaches the P. What do you mean by Q approaches P? The value of h, this point is A plus h comma 0. When the value of h reduces, for example, Q becomes here, h reduced. If Q becomes here, h reduced. So in other words, when h tends to 0, automatically Q will tend to P. So I can say when h tends to 0, this slope of the secant will turn to the slope of the tangent. So slope of the tangent will be limit h tending to 0, the slope of the secant. So f of A plus h minus f of A upon h. This is nothing but the definition of the derivative at a point. So therefore, this is dy by dx at the point x equal to A. So we need not use this limit definition. We can directly calculate derivative and substitute the x coordinate and you will get the slope of the tangent. This is the formula that we can apply to find the slope of the tangent. Now we shall discuss what slope of the normal. What is the relation between tangent and the normal? If this is a tangent, the normal is always perpendicular to the tangent at the point of contact. So if this point is x1, y1 and the equation of the function is y equal to f of x, then the slope of the tangent will be dy by dx at the point x1, y1. What will be the slope of the normal? We know that whenever two lines are perpendicular, the product of the slope will be minus 1. So slope of tangent into slope of the normal should give me minus 1. So slope of the normal will be minus 1 upon slope of the tangent, which is dy by dx at x1 y1. So we can calculate slope of the tangent by using this formula, slope of the normal by using this formula. Now we need to know how will we calculate equation of tangent. Equation of tangent is calculated by using slope point form, because to find equation of any line we need two things, point and slope. So if we have a curve and a point x1 y1 over here, and we want to calculate the equation of the tangent, we'll use the formula y minus y1 is equal to m into x minus x1. And how will we get m? By using the derivative. So dy by dx at x1 y1. So that will give me the equation of the tangent. This will be the equation of tangent. So naturally, equation of the normal will have only one difference. The point for the normal also remains the same. Only the slope will change. Hence, the equation of normal will be y minus y1 is equal to minus 1 upon dy by dx at x1 y1 into x minus x1. This will give you equation of normal. Discuss about the vertical tangent and horizontal tangent. Imagine the curve is of this kind. This is the axis. If I draw a tangent at this point, the tangent is perpendicular to x-axis. This is called vertical tangent. A horizontal tangent can be imagined this way. If I draw a tangent at this point, this is called the horizontal tangent. In a vertical tangent, you can see here the angle is 90. So the slope of the tangent will be tan 90, which is infinity. So the reciprocal of the slope, what is the reciprocal of slope? Dy by dx is the slope. Its reciprocal is dx by dy. So dx by dy will be 0 for a vertical tangent. And for a horizontal tangent, the slope of the tangent would be 0. Therefore, dy by dx will be 0. So if I want to find out where does the vertical tangent occur, I need to equate dx by dy to 0. And I want to find where does the horizontal tangent occurs in a curve, I need to equate dy by dx to 0. Let's look at the special case of equally inclined with the coordinate axis. The tangents are equally inclined with the coordinate axis. What does that mean? One possibility is tangent can be like this. This angle and this angle are equal. We already know this is 90 degrees. This is the curve, this is the tangent. They are equally inclined with both the axis, coordinate axis. So this is 90, so this should be 45. So this also should be 45. Hence, this would be 135 degrees. And we know the slope is the angle made by tan of the angle made with the positive x-axis. So slope will be tan 135 degrees. So minus 1. So if the line is equally inclined with the coordinate axis, if the tangent is equally inclined with the coordinate axis, the slope of the tangent can be minus 1. What about this case? This is also equally inclined. Both makes equal angle with x-axis and y-axis. Therefore, but here the angle would be 45 degrees. In that case, slope would be tan 45. In that case, the slope would be 1. So in short, if the tangent happen to be equally inclined with the coordinate axis, the slope of the tangent or derivative of the tangent, derivative of the curve, at that point would be either plus 1 or minus 1. So this is a condition we will apply whenever the tangents are equally inclined with both x and y axis. The equation of tangent and normal at a point. So here I am going to take a circle whose equation is x square plus y square equal to 25. And I am taking the point on the circle P 3, 4. Check whether 3, 4 is a point of the circle. What should I do? Replace x by 3, 9. Replace x by 4, 16. 9 plus 16 is 25. So 3, 4 satisfies the equation. So 3, 4 is a point on the circle. Now I want to find out what is the equation of tangent and the normal at that point. First of all, I'll find the slope of the tangent. I'm going to find out what is the slope of this tangent. To find the slope of the tangent, what we learned just now is find the derivative at this point. So x square plus y square is 25. Now differentiating with respect to x. you will get 2x plus 2y dy by dx equal to 0. So you get dy by dx is minus x upon y. What does that mean? This means anywhere on this circle, if I want to find the slope of the tangent, minus x coordinate divided by y coordinate will give the slope of the tangent. Becomes a formula for slope of the tangent. Not at one point. Every point you can calculate the slope of the tangent by using this formula. So I can say slope of tangent at P 3, 4 is minus x coordinate 3 divided by 4. So directly I can obtain the slope of the tangent by using the derivatives value. Now I can find the equation of the tangent. Tangent is a line. To find the equation of a line, we need point and slope. Point is already there. Slope we have calculated. Slope we have calculated. So the equation became y minus y1 is equal to m into x minus x1. So y minus 4 is minus 3 by 4 into x minus 3. So x1 is replaced by 4, y1 is replaced by 3, and slope is replaced by minus 3 by 4. So 4y minus 16 is minus 3x plus 9. So 3x plus 4y equal to 25 becomes the equation of tangent. Now I am going to find out equation of the normal. You know that normal is nothing but a line perpendicular to the tangent. So it is a line perpendicular to the tangent at the point of contact. It is a line perpendicular to tangent at the point of contact. So it will be like this. This will be the normal. Normal will be perpendicular to the tangent. So what will be the slope of the normal? Slope of the normal will be minus 1 upon slope of the tangent. So your answer become minus 1 upon minus 3 by 4. That is 4 by 3. You know that whenever two lines are perpendicular, the product of the slope will be minus 1. The product of the slope will be minus 1. So slope of the line perpendicular will be minus 1 upon slope of the other line. So you need to take the reciprocal and change the sign. So slope of the tangent was minus 3 by 4. So slope of the normal will be 4 by 3. So equation of the normal, y minus y1 is 4 is equal to m into x minus x1. So the formula remains the same, only the slope will change, nothing else. So 3y minus 12 is 4x minus 12. So 4x minus 3y equal to 0 becomes the equation of the normal. You can see the normal will pass through the center of the circle. That's why the constant term is missing there. So this is how you can find equation of the tangent and equation of the normal. So first thing, if I want to find the slope of the tangent, take the equation of the curve, differentiate it, that whatever the derivative you get, it is a formula to calculate the slope of the tangent at every point. So we want slope of the tangent at 3, 4. So we replace x by 4 and y by 3, you got the slope of the tangent. After we got the slope of the tangent, what we did? We found out the equation of the tangent, slope point form. Y minus y1 is equal to m into x minus x1. After we got equation of the tangent, we wanted to find the equation of the normal. Normal is a line perpendicular to tangent passing through the point of contact. So I can say this, because the normal is perpendicular to the tangent, slope of the normal will be reciprocal of the slope of the tangent with a negative sign. Take the reciprocal and change the sign. Once you get the slope of the normal, you can find the equation of the normal by using the same formula, because it is a standard formula to find out the equation of any line. And after that, we get the equation of the normal. Let's have a look at this problem. A curve y is equal to 3x square minus 6. So let's imagine the curve to be something like this. Y equal to 3. Let's imagine this curve. There is a point on it whose x coordinate is 2. So let's imagine the point here whose x coordinate is 2. Then we can draw a tangent to this curve. Let me draw the tangent to this curve. This is a tangent to the curve. This tangent makes angle theta with the positive x-axis. And we are asked to find what is the value of this theta. Then this theta is known as the angle of inclination. The angle of inclination made by the tangent at the point on the curve whose x coordinate is 2. First of all, if x coordinate is 2, how much will be the y coordinate? You can replace x by 2 here, 4, 4 into 3, 12, 12 minus 6. So y coordinate is 6. It's not necessary, I've just calculated it. So first point is, I need to find out the slope of the tangent. We have learned how to find the slope of the tangent at the point. What we must do? Take the equation of the curve, differentiate with respect to x, substitute the point where you want to find the tangent at 2, 6, so x is 2, we don't require y, 6 into 2 gives you 12. So if slope of the tangent is 12, slope of the tangent at that point is 12, which means if theta is angle, tan theta is 12, so I can say the inclination theta is tan inverse of 12. So tan inverse of 12 will be the inclination of the tangent at the point 2, Let's try to understand the difference between the two problems that what we did before. Before, what we had given, equation of the curve was given, point on it was given, and we are asked to find the equation of tangent. In this problem, the curve is given. This is the equation of the curve. Let's imagine this is a curve whose equation is y is x squared plus 2x minus 4. Then the point on the curve is not given. Instead, they are given as a line which is perpendicular to the tangent. Imagine the line is something like this. Let's say this is the line whose equation is x plus 14y minus 3 equal to 0. The slope of this will be minus a by b, minus 1 upon 14. In this case, I want to explain to you one small stuff. Equation of any line is ax plus by plus c equal to 0. All of you have by hearted and get the slope of the line is minus a upon b. Imagine you have a confusion. What you do is just differentiate it. A plus b into dy by dx equal to 0. So dy by dx will be minus a upon b. You have noticed that the derivative of a linear equation is a constant because on that line, everywhere the slope of the tangent remains the same. Slope is always constant in a line. Whereas if you take a curve, if you find the derivative, we'll have x and y in it, which means it varies according to the point. Whereas in case of line, everywhere, any point you take, the slope at that point remains the same. So that's why dy by dx is a constant minus a by b. If you use that over here, even if you differentiate this also, you can get the slope of the line. If you want to find the slope of the line, 1 plus 14 into dy by dx equal to 0. So dy by dx is minus 1 by 14. So whenever you forget now onwards, slope of any curve at a point, just find the derivative and that gives you slope. Okay, so slope of the line given to me is minus 1 by 14. So what will be the slope of the tangent? Let me draw the tangent. Tangent should be perpendicular to it. So it should touch this curve only at one point and it should also be perpendicular. So this will be the tangent. Now I am asked to find what is the equation of this tangent. So to find the equation of tangent, what I am going to do is, I need to derive the coordinate of this point P. But I know the slope of the tangent is dy by dx. So y is x squared plus 2x minus 4. When I differentiate, dy by dx is 2x plus 2. Now I also know that slope of the tangent here is, but slope of the given tangent is 14. Slope of the given tangent is 14 because slope of this line is minus 1 by 14. Any line perpendicular to it, take the reciprocal and change the sign. When you take the reciprocal, become 14, change the sign, became plus. So, slope of the tangent is known to you. Now I can get what is the equation of the tangent by finding the coordinate. So I'm going to equate both. This is also slope of the tangent, this is also slope of the tangent. So I can say 2x plus 2 should be equal to 14. From this I will get x equal to 6. Which means the coordinate of this point is 6. X coordinate. And y coordinate you can obtain from here. Y is x square plus 2x minus 4. So 6 square plus 2 into 6 minus 4, that is 36 plus 12 minus 4 is 8. So it becomes 44. So the coordinate of point is 6, 44. So we got the coordinate, we got the point, we got the slope. Now we can find the equation of the tangent. So equation of tangent is y minus y1 is equal to m into x minus x1. We need only two things to find the equation of tangent, point and the slope. So y minus 44 is equal to 14 into y minus y1, slope is 14 into x minus 6. So I can write y minus 44 is equal to 14x minus 84. Now bring them to one side. So I can write 14x minus y minus 14 equal to 0 becomes my equation. Now we are given equation of the curve in parametric form. Every point on this curve, x coordinate is defined by a sin cube theta and y coordinate defined by a cos cube theta. That means as theta's value keep on varying, you will get all the points on the curve. We are asked to find equation of tangent and equation of the normal at the point theta is pi by 4. So when theta is pi by 4, what is the point? Point on the curve. X coordinate is given by a sin cube pi by 4 and y coordinate is given by a cos cube pi by 4. So I can say the point's coordinate can be defined as, let me denote the point by p, a upon 2 root 2 and a upon 2 root 2. How did I get 2 root 2? Sin pi by 4 is 1 by root 2. If you cube 1 by root 2, the whole cube, you will get 1 upon 2 root 2. That's how I got this 2 by root 2 in the denominator. Now, after I got the point, next my aim is to get the slope of the tangent. And you know the slope of the tangent is dy by dx. But to calculate dy by dx, it's parametric equation. So I will write dy by dx is dy by d theta divided by dx by d theta. So dy by d theta, a into derivative of cos cube theta, 3 cos square theta into minus sin theta, divided by derivative of x, a into 3 sin square theta into derivative sin theta, that is cos theta. Now we can cancel the common terms here. A gets cancelled, 3 gets cancelled, 1 sin will get cancelled, 1 cos will get cancelled. So you have a minus sign and a cos upon sine gives you minus cot theta. So slope of the tangent at any point on the curve is given by this formula, minus cot theta. That means at theta is pi by 4, you will get the slope of the tangent at that point. So dy by dx okay, I'll write off directly. Therefore, slope of the tangent at theta is equal to pi by 4 is equal to minus cot pi by 4, which is minus 1. So we got m is equal to minus 1. Slope we have got. So slope of the tangent we got. Slope of the normal also we have to find. So I'm going to find both. Equation of tangent I'll find first. Equation of tangent. Y minus y1. Y1 is what? A upon 2 root 2 is equal to m minus 1. X minus a upon 2 root 2. So I can write, when you open the bracket, x plus y equal to 2a by root 2. This both will get added. This is a plus, this also will get plus, 2 will get cancelled. So x plus y equal to a upon root 2 or a root 2 by 2 you can write, or you can cross multiply, etc. And for the equation of normal, it will be y minus y1. Y1 will be a upon 2 root 2 is equal to m. Slope of the tangent is minus 1. What will be the slope of the normal? Reciprocal, change the sign. When you reciprocate, 1 will be 1 only, change the sign, plus 1 into x minus a by 2 root 2. This time a 2 root 2 will get cancelled. So x minus y equal to 0 becomes the equation of the normal. So the equation of the normal is x minus y equal to 0 and the equation of tangent is x plus y equal to a upon root 2. Let's discuss equation of tangent. First case, parallel to x-axis, what will be its equation of tangent? and perpendicular to x-axis, what will be the equation of tangent? First, let me discuss about the equation of tangent parallel to x-axis. Imagine this is a curve and imagine this is a tangent. This tangent is parallel to x-axis. What will be the speciality? Let's assume this point of contact is x1, y1. You know that when a line is parallel to x-axis, slope is 0. So dy by dx will be 0. The first point. If a tangent is parallel to x-axis, slope at that point will be 0. So you will be able to get the coordinate by using this. Now, imagine the coordinate of this point happened to be 2, 3. Once the tangent is parallel to x-axis, its equation is y is a constant. So y coordinate everywhere on this line will be the same as the y coordinate at this point. So the equation will be y equal to 3. So the equation of the tangent will be y equal to 3. And naturally, the equation of the normal will be x equal to 2. So equation of normal will be x equal to 2. So we can, whenever they ask you, find the equation of tangent parallel to x-axis, equate the derivative to 0, get the coordinate, and y equal to a constant will be the equation of tangent, and x equal to a constant will be the equation of the normal. Now let's take the case, you suppose that the curve is, tangent is perpendicular to x-axis. When it is perpendicular to x-axis, you know that slope of the tangent is dy by dx. If slope of the tangent should be infinity, because whenever a line is perpendicular to x-axis, tan 90 is, theta becomes 90, slope becomes tan 90 infinity, which means dx by dy will be 0. So this is important to note. For a tangent, dy by dx will be equated to 0. For a tangent, if it is perpendicular to x-axis, dx by dy will be equal to 0. Tangent parallel to x-axis, dy by dx is equated to 0. Tangent perpendicular to x-axis, dx by dy should be equal to 0. From that, you will get the coordinate. Let's imagine the coordinate is a comma b. Then the equation of the tangent will be x equal to a, because any line perpendicular to the x-axis will have equation x is a constant. So whatever the x coordinate, that will give you the equation of tangent x equal to a, and the equation of the normal will be y equal to b. So this need to be remembered. So just differentiate equal to 0, you will get the slope of the tangent parallel to x-axis. Differentiate dx by dy equal to 0, you will get the slope of, you will get the point on where the tangent is perpendicular to x-axis. Here we are given the curve to be y is equal to x into x minus 2 the whole square. We need to find the tangent, we need to find the point where the tangent is parallel to x-axis. When tangent is parallel to x-axis, what happens? dy by dx at that point will be 0. So what we'll do? We'll take the function y is equal to x into x minus 2 the whole square. We'll calculate the derivative at that point. The derivative at that point will be dy by dx is equal to 2 into x minus 2 into d by dx of, I'm opening the bracket, x squared minus 2x. I hope you understood. U square derivative, 2u derivative of u. That is 2 into x minus 2 into 2x minus 2. I can take a 2 more common. 2 into x minus 2. If I take common, x minus 1. Now I can write this as 4x into x minus 1, x minus 2. This will be the derivative. Now when does the derivative become 0? So dy by dx becomes 0, implies 4 into x minus 1 into x minus 2 should become 0, which means x is 0, x is 1 and x is 2. The points where the tangent become parallel to x-axis have x coordinates 0, 1 and 2. Now let's find out what are their corresponding y coordinate. When I put x as 0, 0 into 0, so 0, 0 will be first point. Next point, q. Put x as 1, 1 minus 1, 1 will become 1, 1. Then at third point, r, x coordinate is 2, 2 minus 2 will give you 0 and 0. These are the points where the tangents becomes parallel to x-axis. Whenever a line is parallel to x-axis, its y-coordinate will be a constant. So if a line is parallel to x-axis, its y-coordinate will be a constant. So y-coordinate here is 0, y-coordinate here is 1, y-coordinate here is 0. Therefore, the equations of the tangents are equation of tangent at P00 is y equal to 0. At Q11 is also y equal to 1. At R20 is y equal to 0. This will be the equation of the tangent at 3 different points. So basically, if I drawing the graph of it, the graph will be a 0, 0. Here it will be there, then 1, 1, then 2, 0. So like this you will get the curve. Here the tangent is parallel, here the tangent is parallel, here the tangent is parallel. That's how you get the equation. This is x-axis, this is x-axis, this is y equal to 1, parallel to x-axis, passing through 0, 1. So like this you will get 3 curves. I'll draw it a little more clearly. You will have 1 point like this, then you will have 1 point like this, then you will have 1 point like this. These are the points where the tangent becomes parallel to x-axis. This tangent is parallel to x-axis, this tangent parallel to x-axis, this tangent is parallel to x-axis. That's how we get 3 equations. Now, finding the unknowns, that's the next type of question. What is given to us? This is a curve. The tangent is at 2, 3 is y equal to 4x minus 5. So imagine the curve, something like this. There is a point 2, 3 here. The tangent at this point is given to you, y is 4x minus 5. And you are also given the equation of the curve, y square equal to ax cube plus b. We need to find out the unknowns a and b. What are the conditions that we have? First and foremost thing, point 2, 3, where it is? It is on the curve. It is also on the tangent. It is also on the tangent. It is also on the point on the curve. Since I want to find a and b, what will I apply? 2, 3 will satisfy this equation. This is one thing I can apply. Second thing I can apply is the slope of the tangent here we can see is 4, y equal to mx plus c, or dy by dx is 4 here. And slope of the curve, slope of the tangent at 2, 3 is 4. So dy by dx at 2, 3 should be 4. So these two conditions we apply, we get a and b. So let me start with the first derivative. Y square equal to ax cube plus b. 2y dy by dx is a into 3x square. So from here dy by dx is 3ax square upon 2y. So dy by dx at the point 2, 3, which means I need to replace x by 2 and y by 3. So 3 gets cancelled, 1, 2 get cancelled, so 2a. Now we know the slope of this line. Slope of y equal to 4x minus 5 is 4, which means 2a should be equal to 4, which implies a should be 2. So a's value we have obtained. Now only b's value is left. For that we are going to apply 2, 3 satisfies y square equal to ax cube plus b. So 3 square is a into 2 cube plus b. A's value already we know. So 9 is equal to 2 into 8 plus b. So b is 9 minus 16, which is equal to minus 7. So b's value is minus 7. So a's value is 2 and b's value is minus. Now we shall discuss what is angle between the curves. Angle between the curves is nothing but, so imagine there are two curves. First we will take their point of intersection. We will draw the tangents to both the curves at their point of intersection. The angle between the tangents at their point of intersection is the angle between the curve. Angle between the tangents where the two curves intersect. Whatever the angle between the tangents is the angle between the curves. If this happen to be perpendicular, then we say the curves intersect orthogonally. Then what we say, if the angle between the tangents happen to be 90 degrees, what do we say? We say the curves intersect orthogonally. Okay, so what we must do, if I want to find out the angle between the curves to these two parabola, y square equal to 4x is a parabola, x square equal to 4y is a parabola. So first I will have to find the point of intersection. To find the point of intersection, I need to first solve both the equations. So my first step is find point of step 1. Find the points of intersection. Point or points of intersection. That will be my first step. Now to calculate the point of intersection, what should I do? I need to solve both the equations. Make one of the variable as a subject. I'll make y as subject here. X square equal to 4y. It implies y is x square by 4. Now substitute in the second equation. Y square equal to 4x. This is equation 1. This is equation 2. Substitute 1 in 2. So you will get x squared by 4 the whole square is equal to 4x. That became x raised to 4, 16 into 4, 64 x. That is x raised to 4 minus 64 x equal to 0. Let me solve it. X into x cube minus 64 is 0. That is one possibility is x0, another possibility is x cube is 64, that means x is 4. So there are 2 points of intersection. So these two curves intersect each other at 2 points. One point I have got x coordinate 0. When x is 0, how much is y? When x is 0, y is also 0. And when x is 4, put here 4, 16 by 4, y is 4. So the point of intersections of the two curves are 0, 0 and 4, 4. Now what I'll do? I will find out the slope of the tangent at 0, 0. I'll find out the slope of the tangent 4, 4. Then I can find the angle between them. So I'll take the first curve. Y square equal to, first curve I'm taking, y square equal to 4x. Y square equal to 4x. When I take the derivative, 2y dy by dx equal to 4, which implies dy by dx is 2 by y. This is my first slope of the tangent. Then I take x square equal to 4y. So when I differentiate 2x equal to 4 into dy by dx. From this I get dy by dx is x by 2. So when x is 0, what is the slope? Now at 0, 0, let's say slope of the first tangent, f1, is 2 by y. Y coordinate is 0, so you get infinity. What does that mean? The tangent is perpendicular to x-axis. So the first curve's tangent at 0, 0 is perpendicular to x-axis. And second one's m2 is x by 2. So 0 by 2, that is also 0, which means the second tangent is parallel to x-axis, which means I can say the first tangent is perpendicular to x-axis, second tangent is parallel to x-axis, so the angle between the curves is 90, which implies at 0, 0, the curves intersect orthogonally. Once again I'll explain. One of the slope has got infinity. That means the tangent is perpendicular to x-axis. So if I'm trying to draw the curve, it will be like this. First curve is one parabola like this, another curve like this, one intersect at 4, 4, another point of intersection 0, 0. The tangent to the first curve, one curve, tangent to this curve, which is this one, y square equal to 4x. And this is x square equal to 4y. At the origin, they intersect. So one of the tangent gives you infinity. That means, which is the tangent? This is the tangent, that is the y-axis is the tangent to this curve. And other gives you slope 0, which means the tangent to this curve is this one, x-axis. So angle between these two is 90, therefore the curves intersect orthogonally at the origin. Now let's have a look at the next point, 4, 4. What will be the angle between the tangents at 4, 4? So let me take the slope of each tangent. What is m1? m1 is slope to the first one. So at 4, 4. m1 is 2 by 4, which will give you 1 by 2. m2 is x by 2. Here it is 2 by y. x by 2, that is 4 by 2, which will give me 2. Now that means one tangent like this, one tangent like this, and finding the angle between them. So tan theta is equal to, what is the formula to find angle between the lines? Tan theta is m1 minus m2 upon 1 plus m1 and 2. So I will get half minus 2 upon 1 plus half into 2, which will give me answer 3 by 2 divided by 2, which gives me answer 3 by 4. So theta is tan inverse 3 by 4. So the angle between the tangents at 4, 4 is tan inverse 3 by 4.